All right, let's investigate what happens if the lines are not horizontal or vertical lines. So let's just talk about a point here, say -2, -2. Let's draw another point, say -1, -1. We know there's a unique line that goes through these 2 points. So let's plot some other points that are possibly on this line, say 0, 0, 1, 1, 2, 2. So once we connect them, here's our unique line that goes through these 2 points right there. How would we describe the relationship of x and y coordinates that are on this line? Well, every point that you see here, -3, -3, 4, 4, 5, 5. So you can see that the y coordinate is the same as x coordinate for all points on this line. So this is the line y equals x. Let's see if there are any other characteristics of this line and the points that are on this line. 1 up, 1 over, 1 up, 1 over. So if you take a point on the line, then the only way you can move up and to get over back onto the line is if you go 1 up, 1 over. And it doesn't matter where you start, you always go 1 up, 1 over, and you end up on the line, no matter where you start. This unique characteristic of the line is referred to as the slope. And look what happens. 1 over 1x, that's the same as saying y equals 1x. So it sounds like this coefficient of x may have something to do with how these points are arranged on the line. All right, let's take a different example. So let's start with -2, 6. What's the relationship between this point and then the next point on the line? So let's say another point, -1, -3. There's a unique line going through these 2 points, and what is the characteristic of that line? So here's 0, 0, here is the 1, 3, and here is 2, 6. So if you connect those, you'll see that the relationship between the x and y coordinate is that y is equal to 3x. Now let's start with the point on the line, 3 up, 1 over, 3 up, 1 over, 3 up, 1 over, and that will happen no matter where you start. So take a look, 3 up, 1 over, 3 up, 1 over. It doesn't matter where you start on the line, no matter what point you pick, you're always going 3 up and 1 over. So this line can be written as 3 over 1x. So clearly this number is affecting how much this line is tilted. Does that make sense? What it really is a vertical stretch. That's what's really happening. But it looks like when it's a line that it's tilted. If you work with any other graph, you'll see that this coefficient in front of the x is controlling vertical stretching of that graph. All right, let's try another example and see if that is observant. So let's start with -6, -2, a point on the line. Let's say another point is -3, -1. What's the relationship between this point and this point? You can see that whatever the y coordinate is, x is now 3 times that much. All right, so let's plot a few more points on the line and connect them. So y coordinate is 1/3 of x, or x coordinate is 3 times y. So another way to write y coordinate is 1/3 x. 1 over 3x. So we would, like how we observed here, we would say 1 up and 3 over. So let's see if that happens. 1 up, 3 over. So you can see that this characteristic is working. So this number here is referred to as the slope of that line. And so we define the slope of a line as this ratio of rise over run. And the equation of a line that passes through 0, 0 and has a slope of m is given by y equals m times x. This m, which in this case is 3, in this case is 1/3, in this case it's 1, is referred to as the slope or rise over run. So slope of a line is rise over run. So formally, we're going to define slope of a line as the rate of change in the y-coordinate with respect to 1 unit change in the x-coordinate of a non-vertical line. Remember, we use the letter m to denote the slope, No slope is associated with vertical lines. We say vertical lines have undefined slope. That does not mean no slope means zero slope. Remember, zero slope means you have a horizontal line. There is no change in the y-coordinate per unit change in the x-coordinate. That's what horizontal line refers to. So no slope is different than having zero slope. Keep that in mind. All right, what is the meaning of a slope then? Let us consider an equation that describes total cost y for purchasing x units of some quantity, let's say rice. So the rice costs 70 cents per pound. Then purchasing x pounds of rice would cost 70 cents per pound times x pounds. So y equals 0.70x. It's going to give us the price for x pounds of rice. Okay, so basically 70 cents or 7/10, or that means what? It costs $7 for every 10 pounds of rice. That's another way to think of this. So meaning of the slope, let's see what it means in terms of the graph then. Y equals 7/10x or 0.70x. That means cost $7 for every 10 pounds. So if you order 10 pounds of rice, it's going to cost you $7. If you order 5 pounds of rice, you're going to be, that's half of 10 pounds. You're going to have to pay $3.50. So 7 pounds we saw was 10. What happens if you order 15 pounds of rice? Then you have to pay $10.50 because 15 is 5 more pounds. So every 5 pounds is going to cost you $3.50, or every 10 pounds is going to cost you $7. So there's our line, y equals 7/10x. Now, what about this part of the line? If you buy no rice, 0 pounds of rice, you have to pay nothing. But does this part of the line make sense? The answer is no, because you can't order negative pounds of rice. So sometimes, even though you're looking at a line, you may only look at part of a line, depending on what situation that line is representing. So slope of the line is rate of change. It's the cost of rice per pound, right? We said it's the change of the y-coordinate per unit quantity of x. Or we can also think of it as that it costs you 70 cents per pound of rice. Those are all the different interpretations of slope. All right, so computing slope of a line. On a graph, the change in y-coordinate between 2 points on the line is called the rise, and the change in x-coordinates between 2 points on the line is called the run. So rise over run will be our slope. That will give you the rate of change. So slope of a line is defined as the ratio of rise over run, rise divided by run. Now, how do you compute that when you're given actual coordinates? When you want to refer to, remember, arbitrary coordinates, first coordinate, second coordinates. So first point, we're going to say x1 refers to x coordinate of the first point. y1 is y coordinate of the first point. X sub 2 refers to x coordinate of the second point. Y sub 2 refers to y coordinate of the second point. So y2 minus y1 over x2 minus x1, y coordinate of the second point minus y coordinate of the first point, divided by x coordinate of the second point minus x coordinate of the first point. That will give you the ratio of rise over run. It's not important which point you use first, as long as you're using the correct coordinates. So I can also say slope is y1 minus y2 over x1 minus x2. So don't get hung up on the y1 and the x1, or the y2 and the x2. It does not matter. However, the coordinates you use here, the first y coordinate you use, the same x coordinate needs to be down here. That's important. Okay? All right, let's take a look at then perpendicular lines. We know that slope of perpendicular lines are negative reciprocals of each other, or that the product of slopes of two perpendicular lines is -1. Why should I believe that? Well, let's take a look at two lines. So here's line 1, passing through points A and C. The slope of this line is going to be rise over run, b over a, right? So the slope of this line is b over a. How do I get a perpendicular line? I'll have to rotate this line 90 degrees. So here we go. Rotate that 90 degrees. So it will look like that. Okay, what's the slope here then? First of all, you can see the direction of that line changed. So the slope of this line is going to be the negative of the line that was here before. Let's have both lines together so you can see. So line 2 slope is going to be a over b, and a negative rise over run, a over b. Negative because this was the positive slope. This is going in a different direction. So that's why the two lines have negative reciprocal slopes. You can see it just from looking at this picture. All right, so let's take a look at line y equals 3x. Rotated 90 degrees, what do you think its slope? We said negative reciprocal of 3. Reciprocal of 3 is 1/3. Negative reciprocal would be negative 1/3. So slope of the line is y equals negative 1/3 x, or negative x equals 3y. You can think of it like that as well. All right, let's take a look at the line y equals 1/3 x. What would be line perpendicular to that? That would be y equals negative 3x, because that would be this line, slope of that line. So negative reciprocal. So this gives you an idea of how we can go about finding equations of lines perpendicular. The slope is easier to find if you remember that slope of the perpendicular lines are negative reciprocals of each other. And no matter where the line is. It's harder to get this equation. We have to do a little more work for that, right? All right, so in general then, equation of a line that passes through the origin is y equals slope times x. Slope of two perpendicular lines are negative reciprocals of each other. Slope of a horizontal line is 0. Slope of a vertical line is undefined. That's what we've done so far. All right, go ahead and do this for video log.